Okay, in this video I'm going to cover binomial distribution. What is binomial distribution? That's a distribution based on discrete variable. So there are discrete variables, and there are variables that represent continuous continuous value variable. What's the difference between continuous one? I believe I have explained that, but I'll go over one more time. This never hurt to repeat. So the continuous variables represent the continuous value, like let's say water, gas, time, right? But discrete, everything that you can count it in, let's say one envelope, two envelope, one phone calls, two phone calls. So binomial distribution represent discrete variables. And once we done binomial distribution, after that I will continue. I will start the normal distribution that will represent the distribution continuous variable. So let's start with binomial distribution. So what is binomial distribution? That is the distribution objectives. Let me cover it. So we are going to learn if the probability experiment is a binomial experiment. We will learn to find binomial probability based on binomial probability formula. And then we will learn find binomial probability using table, in our case, binomial table, graphing binomial distribution, finding the mean, standard deviation, and so on. So, what are characteristics for binomial experiment? Characteristics are following. The experiment we repeat for fixed amount of trials, and each trial also is very important, independent of each other. So the occurrence of one trial has nothing to do with occurrence of another trial, and it has to be fixed amount. For example, if I go to the beach to see let's say dolphins for 5 days, that's a fixed amount. But if I say I went to the beach for more than 5 days, that is not fixed amount. More than 5 days, how many days? God knows, right? Okay, next one. There are only two possible outcomes, success or failure. Now, this, don't take it, accept it as these two outcomes, literally failure or success. The subject of our interest we will identify as a success, and the complement will be failure. For example, if I am interested to figure out how many computers are defective, let's say we received, the corporate received computers, and I'm interested to know how many computers are defective and need to be repaired, that will be my success, because that's my subject of my interest. And the ones that are working properly, that will be failure. So don't take it as a literally success or failure. So the subject of our interest we identify as a success. Next, and obviously there can be only two outcomes. The probability of success is the same for each trial because they are independent. So success is the same for each trial. Let's say going to the beach to see dolphins, it's a 50-50 chance, right? And every single day I go, it's going to be same 50-50 chance. So it's the same probability. Random variable x, this is what we need to know. X is always counted as a number of successful trials. So there are 4 properties or 4 characteristics for binomial experiment. Okay. So now notation. N is a total amount of trials. I went to the beach 5 days, so N will be equal 5. Probability of success, there is a 70% chance I will see dolphins. So, and that means 30% probability of failure. It's a chance that I won't see dolphin. X is a variable that represents amount of success. And X can be from 0, none of them happened, and all the way maximum to N, which will be all of them happened. And obviously, successful amount of trials cannot be more than total. So it can be from 0 to total N amount of trials. Okay, let's identify binomial experiment. Decide whether the experiment is binomial. So a certain surgical procedure has an 85% chance of success. So 85% chance of success. So probability of success is 85%. A doctor performed the procedure on 8 patients. So total we have N will be 8 patients, right? Random variable represent successful surgeries. So we need to identify whether experiment is binomial or not. So let's go over every single one of them. So it's experiment fixed amount of trials. First one. Great, it's not working. Wow, it's not working. Okay, that's all right. So fixed amount of trials. In this case, we have total 8 trials, right? It's a fixed amount of trials. Next, there are only 2 possible outcomes, success and failure. If I come back, what do we have? Either a performed procedure. So it's either successful surgery or not successful surgery, correct? Next, probability of number 3. Probability of a success is the same. Of course, it's 50-50 probability, so it's either successful or not successful. And the last one, random variable X counts the number of successful trials, which is in this case, yes, X is a number of successful trials. So what we can draw condition. Oh, here it is. It's everything. It already says everything I went over. Oh, I'm sorry. When I said probability of success, it says 85%. So not 50-50. 85%, sorry. So that means we are dealing with binomial experiment. Here they put down everything I already did. So if probability of success 85, probability of failure will be 15%, right? 100 minus 85, or 1 minus 0.85. Probability of successful surgeries, none of them successful, only 1 successful, 2 successful, 3, and or all the way to all 88 of them are successful. Next one, decide whether the experiment is binomial or not. A jar contains 5 red marbles, 9 blue marbles, and 6 green marbles. Okay, you randomly select 3 marbles from the jar, pick up the marble from the jar without replacement. Just the fact it's without replacement, it already make it dependent, right? Because it will be less total, less amount will be less. But it's besides of that, you picked 3 of them. So random variable represent the number of red marbles. So let's explore, since we have here already. The probability of selecting a red marble on the first trial is 5 out of 20. Why 5? Because we wrote down total we have 5, correct? In total we have 20. 5 plus 9, 14. 14 plus 6. What was 6 of them? 6 green one. Okay. Okay, I think This is not working again. That's okay. All right, because the marble is not replaced, the probability success rate for subsequent trial is not longer than 5 over 20 because it's going to be less, right? You reduced, took away one red marble, so will be left there 19 total, correct? The trials are not independent, exactly, because from 20 we will get now total 19. And therefore, this is not a binomial distribution. Now, the formula for binomial distribution. We forget about this one. And we are using only this formula. Even if in explanation of homework you have this one, then you don't want to use this, you move and use this one because this is easier. So N is a total amount of trials, P probability of success, Q is probability of failure, X number of successful N trials. So let's go solve. What is interesting here, probability of success, you raise to power amount of successful trials, and probability of failure, you raise to power of amount failing trials, because if total N, probability of successful trials is X, that means failing trials are N minus X. Correct? Okay. So, how we are going to, now let's solve some examples. So here it is. Microfracture knee surgery has 75% chance of success. So probability is equal 0.75 with degenerative knees. The surgery is performed on 3 patients. So total N is 3 patients. Find the probability of the surgery being successful on exactly 2. So we need to find probability of being successful of exactly 2. So how we are going to solve this problem? You don't want to go through here. So this is what we are going to use. This is that formula I canceled, but here it is. So this is, let me write down this formula, n factorial over n minus x factorial times x factorial, and then p to power x to power q to power n minus x. So our n, excuse me, it's 3 factorial. N minus x, it's gonna be 3 minus 2, and then factorial, x is gonna be 2 factorial. Probability of success, it was 0.75, right? Here I wrote down. By 0.75%, they wrote down as a 3/4 fractionally. I don't know why they use fraction, but that's what it is. This 3/4, it's a 75, 0.75 to power 2, because probability of success is number 2. Then probability of failure, excuse me, probability, let me drink water. Then probability of failure, if total n is equal 3, successful is x is equal 2, then failure will be n minus x, right, which is equal 1. Therefore, we have here 1. Q to power n minus x, here it is. So what do we get here if you plug and solve it, because they solve it here with fractions, which I don't like it. So 3 factorials, let me see, 3 times 2 times 1. 3 minus 2 is 1 factorial, which is same 1. 2 factorials is a 2 times 1. So 2 and 2 is gone. Here will be 0.75%, 0.75 to power 2, and then times 0.25 to power 1. If you do this math, so practically will be 3. Here will be left only 3, right? 3 times 0. This is times 0.75 squared times 0.21. You should get approximately 0.422. Okay? So, binomial probability distribution. So here it is, n is equal 3. So they calculated for 0, none of them, so which means x is 0, you will get result 0.0016. X is equal 1, so those are, they took x from 0 all the way to 3, 0.141. X is equal 2 will be 0.422, and x is equal 3 equals 0.422. So here is example. That this is so practically here they used all cases because n is equal 3, right? So they use x is equal from 0, 1, 2, and 3. So they plugged all numbers and calculated. That's all. So here is example. Let's see what we have. In a survey, US adults were asked to give reasons why they like texting on their cell phones. 7 adults who participated in the survey are randomly selected and asked whether they like texting because it's a quicker than calling. Great binomial probability. So here we have 79% answer for this reason, 75 answer for this reason, 56 answer for this reason, and so on. So what we are going to get, 56% of adults like texting because it's quicker than calling. And that's what they want to know, right? Like texting because it's quicker than calling. And that is 56%. Correct? Okay. So total, they questioned 7 people. Probability of success, 56% answered this way, which means Q will be 1 minus 0.56 will be 0.44, and X goes from 0 all the way till 7. Well, usually when students see that, they say, wow, wow, wow. So you skip this and use the formula that I gave you, n factorial. Actually, you can find on internet binomial distribution probability calculator. If you search it, you will find it. And then n minus x factorial. This is probability of x. And then x factorial, p to power x, q to power n minus x. And you will get this result if you plug x is 0, 1, 2, 3, 4, 5, 6, 7, and so forth. Okay? So here you have all these. You can search for free calculator for binomial probability. Search for it, free calculator for binomial probability, and it will bring it to you. All you have to do, plug your x's, all data that it will ask, and you will get result. What is interesting, if you add them up, you're supposed to get 1 or approximately 1, because if those are approximate values, it should be approximately 1, which is equal 100%. Okay? And this is your binomial distribution. Let me see what kind of technology they use. Here they use Excel. I can show you Excel. So if you read the problem, so we have probability of success 0.67, total amount is 100, and amount of the successful trials is 75. So those are, you can use for Minitab T8384. A lot of students have it. And this is the function binomial, binom PDF. And they plug here, what is our 100? 100 is n. 67 is the probability of success. Okay, 75 if you're x. You plug in there these values and you will get the result. In Excel, it's a formula binom distribution. Again, first you plug x, and then second you plug total amount of n. Third, 67 you plug 0.67 you plug probability of success. And here's the attribute, you put false. I don't remember what is false and true. If you read it, you will see that indeed it's gonna be false. If not, then you can, if you are not good with Excel, then all you're gonna do, or I can show you, I will record Excel how to find it and put it there so you can learn it. And you will get that approximately 0.02, which is 2% total chance. Okay, I guess I'll record on Excel this function, how to plug these values on function, so you can learn. All right. All right. So, finding binomial the probability. A survey indicate that 41% of women in the US consider reading their favorite leisure time activity. So probability of success is 41%. You randomly select 4 US women, randomly select, and ask them if reading their favorite leisure time activity probability, they're reading their favorite the leisure time activity, it's reading. Find the probability that at least 2 of them respond yes. So they questioned randomly 4 US women. Okay. So n is going to be equal 4. And then we need to find reading their favorite leisure activities. Find the probability at least 2, which means probability of x is greater equal to, right? Is equal question mark. So at least 2. 2, 3, 4, and that will be it. Okay. Here it is. When you say at least 2, so you're still gonna calculate the way I told you, and this is the answer you should get for 2, 3, and 4. But then, because when it says at least 2, x greater equal to, and total is 4, so probability of 2 plus probability of 3 plus probability of 4, and you get approximately 54.2%. Okay. Using table, so I have to upload table later on. I forgot to upload, so I will upload and come back to record using table.